Hello, this is a tutorial on object-oriented programming and data structures in Java. This is more intended to be a summary/recap rather than being the first time you've heard of these concepts. So I will be going a bit fast through this. So to start off with, we'll talk about the array list. The array list is a resizable array, so it's just a collection of elements. It's got an order, and you're allowed to duplicate elements. I'll add the argument of this command to my list, and then I'll send every argument in the list to the player. So for string arg in list, player.send message list arg, and then we'll compile that. Okay, so if I type /hello hi, then it says your argument hi, list argument hi. And if I type hi2, then we've got hi and hi2 in the list. And if I type again, then we've got hi, hi2, and hi2. So if you want to add to a list, use list.add. You can use list.remove to remove an element from the list. You can either remove it by value, so you could pass a string in, or you can remove it by index, where you pass in the index. And there's a few other methods like remove all to remove everything, remove first, remove last. Remove all actually doesn't remove everything, it removes everything in another list. And then remove first removes the first element of the list and it returns it. Remove last is the same. Remove if takes in a lambda expression, which I'll talk about in a future tutorial. So if you're not familiar with that, just ignore that for now. You can remove every element in the list by using clear. I think that's all for lists. So next up, a hash set. This is similar to a list, except that you're not allowed any duplicate elements, and also there is no order. So if you add something, it might go in the middle of the list, of the set, it might go at the end, it might go at the beginning. There's not really any order. The only guarantee is that if you iterate through it and then iterate through it again without modifying the set, then it'll be the same order. Hash sets are useful because it's really fast to determine if the set contains an element. It's a lot faster than using an array list, so that is why you should use lists. That's why you should use sets over lists. So the methods are similar names. So you've got add, you've got remove. The difference is you've not got remove by index here. You've got clear, you've got contains. So you can check if it contains an argument. So if you're adding an argument, then it'll only add it if it doesn't already contain it. So I'll just do the exact same thing here that I was doing with the lists where I'm adding it. And you'll see that if I add the same argument twice, it doesn't show up. If I add hi, then hi is in the set. But if I add again, then it's not in the set. But if I add hi2, then we've got hi2 and hi. And you can see that because there's no order, hi2 ended up being added before hi. And if I run the command again, then it's the same order, which is guaranteed. But if I add a different value, then it's a different order. And in this case, hi3 happened to be put at the end, but that's not guaranteed. The last data structure I wanted to mention is a HashMap, which is kind of like a hash set. The main difference between a hash set and a hash map is that hash maps have a key and a value. So basically you're mapping a key to a value. So I could insert strawberry and fruit and raspberry and fruit and potato and vegetable. And this is a good way to associate one value with the key, and then you can check what value is associated with the key. So like I could pass in strawberry and get fruit out. And this is a very fast operation. It's the same speed as checking if a hash set contains the key, so that's very useful. Hash maps are probably the most useful data structure there is. I'll do something similar to before. So if you're sending 2 arguments, then what I'll do is put both of them into the list, into the map. Okay, so when iterating over map, you need to call .entrySet, and that'll just give you a set of the entries, and then you can iterate over map.entry string. This syntax, yeah, it's a bit confusing, but you'll get used to it. And then you just call pair.getKey, pair.getValue to get the key or value. So if we compile this and strawberry and fruit, then the map now contains strawberry and fruit. And if I run it again, you can't have duplicate keys, so this will do nothing. We've still got the same stuff. You can change the value, so if I add it, then it just overwrites the value, and now we've got fruit too, but I'll put it back to fruit. And then if I add raspberry, then we've got raspberry and strawberry, and there is no order, just like hash sets. And then I could add potato and vegetable. So it's very common when creating Minecraft plugins that you've got a map where a player ID is the key, and then some piece of data is the value. So maybe like the location of their home, if you're making a set home plugin. Okay, next up is objects. For this, I'm going to make a new class, and I'm going to call it fruit. And if this pops up, just click Don't Ask Again and click Add. So a class is just a type of thing, and then an object is an instance of that class. So fruit is basically like the blueprint of what a fruit is, and then an object would be like an apple or a banana or something. So you can add variables to a class, and you can add a constructor which will run when you create the fruit object. And here we're passing in fruit name into the constructor and setting name to fruit name. And you can also add methods to a class. So I can make this method which takes in a player and it sends them the name of the fruit. And then if I go over here, and I'll just comment this stuff out, you can make a new instance of a fruit by doing fruit equals new fruit, and then I need to pass in my name, so I'm going to pass in apple. And then you can call methods using fruit.printName player, and you can also do fruit.name, and this just returns the variable. So each variable is different for each instance of the class, and each method will use the variables for that instance. So if I actually renamed this to be apple, and then I had a fruit orange equals new fruit orange, and orange.printName player, then orange is the thing stored in here, so when we're printing the name, it sends orange. If I run this code, then I've got apple and I've got orange, because this one's printing apple and this one's printing orange. You can also have interfaces. These force a class to implement a method. So if I make a new interface here, and I call it print name, and I have this function here, this is just meaning that every class that implements this interface must implement the print name method. So it's kind of similar to listener and command executor. These are both interfaces. So you can see listener, there's nothing in it, but it's an interface. And command executor has this onCommand function that we're overriding right here. And then if we put that override, and we should pass in the flare that we need to send it to. And we make this implements print name. Oh, okay, we need to make the method public. And this doesn't change anything from what we had before because we were already printing the name. But this interface requires that fruit can print the name. So if we got rid of this function, we get an error here. Class fruit must either be declared abstract or implement abstract method print name. So you might be wondering, what is abstract? Well, an abstract is basically a class that you can't create an instance of, which sounds a bit useless right now, because if we make it abstract, then we get an error here when trying to make an fruit instance. But the use case is if we can make a class that extends fruit. So let's say apple, and then we write extends fruit. This is just like Java plugin is an abstract class here, and tutorial plugin extends it, and then Java plugin has onEnable and onDisable. So if we go back here, then we see class apple must either be declared abstract or implement abstract method print name. This is because fruit implements print name, so since apple extends fruit, it must also implement the method. So if we put in apple right here, then we can actually get rid of this parameter there, because apple is hard-coded for this class. And then let's also make an orange. And just like this, player.sendMessage orange. And then over here, we can't make a fruit now, but we can make an apple, and we can make an orange. And we don't have to specify apple here or orange here. We can just leave it as fruit if we want, but also we can put apple. And I just forgot to get rid of those. Generally, it's considered good practice to use the fruit instead of apple, just because it's more versatile, and if you later made an orange, your code would still work without having to change anything else. But obviously, if you've got like an extra method inside apple, then you'll need to use that. So if I run this code, it will do the exact same thing as it did before. It's just a different way of doing it. So we've got apple and we've got orange. And we can add another method to this class, so like public void shout name player.sendMessage apple. And because this is part of apple, but it's not part of fruit, if we go over here and type apple.shout name player, this isn't working because we've got a fruit here. If we put this apple, then it works. But if we do orange.shout name player, then it doesn't work because fruit doesn't have shout name. But even if we made it orange, orange isn't an apple, so it doesn't have shout name either, so it doesn't work. And if I show you the code, as you can see, there's apple, then it shouts, and then there's orange. Finally, I'll go over visibility. So you might see we've got some keywords here like public, and then we've got like private here. So I'll just let you know what all these mean. So public means that the thing, it can be a variable, it can be a method, it can be a class, it can be accessed from anywhere. So let's say public int calories. So we've got a variable which is public int, and then if we go over here on our apple.calories, we can access it. Int test. Yeah, so we can access it, but if we made it private, this means that only the current class can access it. So if we go over here, then we get an error. Calories has private access. The final one you can do is protected. This means that subclasses of apple, actually I'll put this into fruit. So, and then if I make shout name and calories, because apple is a subclass of fruit, it has access to calories. But if we go over here, then actually protected also gives access to the field anywhere inside the package. So we have to actually make a new folder. And I'm just going to call this test, and I'll make a new class called test, public void test. And then if I make a new fruit here, so apple equals new apple. And then if I try to access apple.calories, it doesn't work because we're in a different package and we're not a subclass of fruit. And I'll just fix this error by changing the name of the method. And then if I run this, actually we should set apple.calories first. Yes, apples have 500 calories now. And if we reload, we've got apple 500 calories. So yeah, I hope this was helpful. I'll link another tutorial in the description. It's a lot more in depth on object-oriented programming, if that confused you a bit, because it is quite a big topic. And Java is very object-oriented, so you will need to be familiar with it to continue with this tutorial. Thanks for watching. Remember to like and subscribe for more tutorials.